Good morning friends, welcome to JCE Connect. Today we are going to discuss about lab, that is Foundry, Forging and Welding 18MEL38B experiment permeability test. Myself Dr. Anand Kevasmani, Jain College of Engineering, Belagavi. We'll see the outline of the presentation. First we'll see aim, apparatus, observation, procedure, formula, calculation. First we'll see aim. Aim to determine the permeability of the given molding sand. Here we have, that is, the permeability is an important property which every foundry sand must possess in order to enable it to allow the escape of the steam and gases formed inside the mold when molten metal is poured into the latter. Or permeability depends on the shape and size of the sand grains, moisture content and clay content of the sand. It is also affected by the degree of ramming of the mold sand. And here the permeability of the sand sample, this is a sand sample tested by means of apparatus called as permeability meter. This is a apparatus through which you are going to find out the permeability number, which carries an arrangement to allow exit of the controlled amount of air through the sand sample, through this sand sample at a definite pressure difference. The corresponding time taken by the air in passing through the same is recorded separately. Okay, and here we have that is the apparatus. Second slide. In that we have the sand rammer. What are the in the apparatus we are going to use? That is sand rammer, weight balance, distilled water, sand mix. Okay, we are going to use for the preparation of this mold, sand mold, that or the sample we can call. Observation: diameter of the orifice, that is 1.5 mm, diameter of the specimen 50 to 51 mm, height of the specimen, that is 50 to 51 mm, diameter and height will be the same for that specimen, and volume of the air passed through the specimen V, that is 2000 cc. Here we have, that is permeability meter. In permeability meter we have the parts. The above part you are going to call it as a bell jar, and this part you are going to call it as a water tank, and here you are going to have a manometer, and here you are going to have that is multi-position cock, and here you are going to have, that is, the nose piece for fixing the specimen tube. This is the specimen tube which you are going to fix here, and in this you are going to put that sample. This sample you are going to put in the specimen tube. These are the important parts of this permeability meter. And next we will see the procedure. What are the how actually we will do this experiment? That is, first properly mix clay and moisture to the sand and prepare a sand specimen using the sand rammer that I shown in the previous slide. This is a sand rammer. Here we are going to have this sand, distilled water, mix it properly and make the specimen by using this sand rammer. Then the specimen is tightened to the orifice using the nut of the specified size and made airtight. Then next the manometer reading is set to 0. How this is going to set to 0? Here we are going to have a setup, that is 0, 1000 cc, 2000 cc, you have to bring here the mark 0 to this point. Okay, then the manometer you are going to make it as a 0. Then the air tank is kept inside the water tank. This is a bell jar or a air tank which is kept inside the water tank. By keeping the leveler in off position, start allowing the escape of the air through the specimen. Start allowing the escape of the air through the specimen. The time taken for the complete escape of the gases and the manometer reading are noted down. The time taken to complete this they start moving inwards in this water tank, and the gas the air is going to pass through this specimen tube. That here we are going to put the sample in that it is going to pass and flow through it. And the time taken for the complete escape of the gases and the manometer reading are noted down here. And then that manometer reading you are going to see on the permeability meter. Here whatever the pressure you are going to get, that you are going to see, and that you are going to check in this column, and you are going to get the value, that is permeability number. This is how actually we are going to do practically. And we'll see some that is a theory behind this, that is the gas or the water vapor are released in the mold cavity by molten metal and sand. Okay, and what actually happened, the sand must therefore be sufficiently porous. The sand specimen must therefore be sufficiently porous to allow the gas and the water vapor to escape out. The property of the sand is referred to as permeability. The apparatus has an arrangement which allows controlled amount of air to pass through the sand sample, and the time taken for all the air to pass through the same is measured. And the permeability number is going to find out this by using this formula, that is V into H by APT. V means volume of the air in cc, H is the height of the specimen, A is the area of the specimen, P is the air pressure, that is in gram per centimeter square, T is the time taken by the air to pass through the sand specimen in seconds. Okay, this is the formula through which you are going to calculate theoretically the permeability number. And the calculation part I just given you in the previous classes, that you can go through it. Thank you very much for hearing.